Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to network theory or circuit theory. So far we were discussing about the various basic concepts related to alternating current, AC voltage and current. So in this video we are going to discuss about phase of an AC signal. Okay, so a quick review. So the alternating voltage and current, it is a parameter which changes in terms of both magnitude and direction, okay, and the polarity of the voltage, it changes at regular intervals of time, and as a result, when such an alternating voltage is applied to a circuit, it results in an alternating current. The mathematical expression of the voltage is this. This is the waveform. For current it is this, and this is the current waveform. Now if you remember, in the first video I told you that this expression, okay, this is one of the expressions, this is one of the expressions, okay, Vt is equal to Vmax sin omega t, where Vt is the instantaneous value, and also we can represent it as Vmax sin omega t plus minus phi. So here this omega t, which is the angular frequency multiplied with the time, and here the omega t plus phi, where omega t is the same as previous, the product of angular frequency and time, and this phi, which is called as the initial phase angle. This constitutes the total phase, okay, omega t or omega t plus minus phi. This constitutes the total phase of the AC waveform. Okay, Vmax is the amplitude, omega is the angular frequency, t is the time instant, and phi is the initial phase angle. So for the complete expression of any AC parameter, we require the amplitude, the angular frequency, and the initial phase angle. Here omega t, in case there is no initial phase angle, or omega t plus minus phi, this represents the total phase, okay, this. Also I told you there are two ways to draw the waveforms. One is with respect to only time, Vt versus t, and another way is Vt versus omega t. Here it is the time in seconds, this. Here it is phase, omega t is the phase in terms of radians or degree. So for this we'll use this omega t. So here if we use this analysis, Vt is equal to Vmax sin omega t. So here at first, this one, okay, this one, omega t. When omega t is equal to 0 degree or 0 radian, let's say, okay, that. Pi, always remember the relationship, pi radian is equal to 180 degrees. So we take 0 radian, this value. So at this, sin omega t is sin 0, which is equal to 0. So the value is Vmax sin 0, 0 here. Then let's say omega t is equal to pi by 2 radian or 90 degree. So sin pi by 2 is equal to 1. So at this point it is Vmax sin pi by 2, which is equal to Vmax as sin 90 degree or sin pi by 2, that is equal to 1. So this gives us the maximum value at pi by 2. Okay, then we have here it is equal to pi or pi radian or 180 degree. Now sine pi or sine 180 degree, that is equal to 0. Okay, so at this we have Vmax sine 0 which is equal to Vmax into 0 which is equal to 0. So again here we come back to 0. Again here this is 3 pi by 2. Okay, 3 pi by 2. So here sine 3 pi by 2 is equal to minus 1. So here at this we have Vmax into minus 1 Vmax sine 3 pi by 2 which is equal to Vmax into minus 1 which is equal to minus Vmax. So we have minus Vmax here at omega t is equal to 3 pi by 2. Again this is 2 pi or 360 degree. So sine 2 pi is 0. Again we come back to 0. So this 0, pi by 2, pi, 3 pi by 2, 2 pi or 0 degree, 90 degree, 180 degree, 270 degree, then 360 degree, they are all called as the phase of the AC signal. Okay, phase of the AC signal. Now the important thing here is that in this case the initial phase angle is 0. Okay, this we are only considering this Vt is equal to Vmax sine omega t. We have not gone into this plus minus phi, we have not gone into this. So we, for this analysis, for this kind of waveform where the wave is starting from the origin 0, t is at t equals to 0, Vt is equal to 0. For this kind of analysis where we have at t equals to 0 or omega t equals to 0, Vt is equal to 0, the value is 0. Here the initial phase angle, that is equal to 0, 0 radian or 0 degree. Okay, so essentially this becomes omega t, Vmax sine omega t plus minus phi, it becomes Vmax sine omega t, because phi is equal to 0, the initial phase angle is equal to 0. So here omega t is the phase. Okay, at particular phase we have the particular values of the magnitude of the signal parameter. So if we want to define the phase of an AC signal, it is the fractional part of the time period or the cycle through which the quantity has advanced from the selected 0 position or reference. So the 0 position or reference is generally chosen as the origin, 0. Now here it has not passed by any amount. At t equals to 0 or omega t equals to 0 as the reference point, the value is 0. So that's why here the initial phase angle is equal to 0. Okay, so here if we say, if we want to know, let's say what is the phase for which, the phase angle at which the value of the signal is equal to 0. The phase angle for which the value of the signal is 0. So the phase of 0 value is 0, pi and 2 pi, or 0, 180 degree and 360 degree. Now what is the phase of the positive peak? Okay, positive peak occurs at pi by 2 radian or 90 degree. So the phase angle of positive peak is pi by 2 radian or 90 degree. Similarly, what is the phase of the negative peak? So the phase of the negative peak is 3 pi by 2 radian or minus 270 degree. Okay, minus 270 degree. Okay, so this is the important thing related to phase. So when we say phase of a voltage signal or AC current signal, it is the particular value which is drawn with respect to omega t, not t, omega t, the phase angle. So at that what particular angle, what is the instantaneous value of the signal? this signifies the phase. This omega t, the horizontal axis, omega t, it represents the phase axis. This is the phase axis. This is the time axis here. This is the time axis. This is the phase axis. This is the phase axis. Okay, so here phi is equal to omega t. Phi by t is equal to omega, or del phi by delta t, that is equal to the angular frequency. Certain change in phase brought about in certain change in time, that gives us the angular frequency in radians per second. Okay, now this is the phase of the AC signal. Now suppose we want to introduce this initial phase angle part. This initial phase angle part. This. So first we'll consider without initial phase angle. Without initial phase angle, where phase angle is equal to 0 radian or degree. So the waveform of such a signal is this. It starts from 0, acquires a positive peak, then goes to 0, acquires a negative peak, then goes to 0. Okay, whether it is a voltage or current signal, it starts from 0, from origin. Okay, now suppose we have a waveform like this. See, what is the difference between this waveform and this waveform? At omega t is equal to 0 or at t equals to 0, the value of the signal is not 0. It has certain value, this much. It has certain value, this much value. It is not equal to 0. Okay, at this, at omega t is equal to 0, the value of the signal is this much, Vt, this much. Okay, this. So this is equal to, here it is represented as Vt is equal to, let's say this is the positive peak plus Vmax, and this is the negative peak minus Vmax. It is represented as Vmax sine omega t plus phi. Okay, plus phi. This is the value, omega t plus phi, and this much value, this much amount by which it is behind this value, this much value by which this is behind the origin on the phase axis, this value is called as the phase, the initial phase angle. This is the initial phase angle. So here you can see I have used the plus sign. Okay, we have used the plus sign here. Okay, we have used the plus sign, sine omega t plus phi. So such a waveform, AC waveform, is called as a leading waveform, sine omega t plus phi. If it is current, then it becomes IT is equal to Imax sine omega t plus phi. Okay, so this is a leading waveform, and at omega t is equal to 0, the value is Vt is equal to sine omega t is 0, so it becomes Vmax sine phi only, Vmax sine phi. This Vt is equal to Vmax sine phi. This is the amount of phi, the portion which is behind 0. Okay, this much portion, this much portion, this is phi radian or degree. So we have this waveform which is starting from 0, we have this waveform which is starting a little bit behind 0 to the left of 0. Then we have this waveform here. Okay, ignore this part. It is starting from here. Let's see, the pattern is starting from here, okay, to a little bit to the right side, okay, to the right side of the origin. So here, when omega t is equal to 0 at the origin, when omega t is equal to 0, it has a certain value in the negative direction. It has a certain negative value, this much. Here it had a certain positive value, but here it has a certain negative value. So here we will represent this parameter, if it is a voltage, as Vmax. If it is maximum, this is Vmax plus Vmax, and this is minus Vmax. Then we will represent it as Vmax sine omega t minus phi. Okay, sine omega t minus phi. If it is current, it is Imax sine omega t minus phi. So here the waveform at its 0 point, okay, at its 0 point where it is 0, this is called as 0 point. It is slightly towards the right, towards the right of the origin where omega t is 0. The 0 point where Vt is equal to 0, it is slightly towards the right side, towards the right side of the origin. Here in this case, the 0 point, this 0 point is slightly towards the left of the origin. Here it is sine Vmax sine omega t minus phi. This is the amount of phase angle, the initial phase angle. Okay, this is the amount of initial phase angle. So this is the representation of a waveform of this kind, where the 0 point is to the right of the origin by this much amount, which is the initial phase angle phi. Okay, so here at omega t equals to 0, okay, where omega t is equal to 0, this point, the initial value is Vt is equal to Vmax sine minus phi, which is equal to minus Vmax sine phi, this value. This is Vt, which is equal to minus Vmax sine phi, this negative value. Okay, Vmax sine phi, this value, towards the bottom of the magnitude axis. Down means negative, minus Vmax sine phi. This is the initial value at omega t is equal to 0 at the reference point or the origin. Okay, so the 0 point of the signal occurs after phi degree or radian to the right of the origin on the omega t axis. So this kind of waveform, where the 0 point, the first 0 point occurs to the right side of the origin, that is called as a lagging type signal waveform. This is leading. This is a leading waveform where the 0 point occurs to the left of the origin by phi degree or radian. Here the 0 point occurs to the right of the origin by phi radian or degree. Here it is omega t minus phi, here it is omega t plus phi. For leading it is omega t plus phi, for lagging it is omega t minus phi. The amount stays the same, I mean phi, the initial phase angle here, but here it is positive, here it is negative. minus phi, here it is plus phi. So here the initial value at 0, I mean the origin, the initial value is positive plus Vmax sin phi. That's why it is towards the upper side on the magnitude axis, plus Vmax sin phi at t equals to 0. At omega t equals to 0, Vmax sin phi plus Vmax sin phi, it is positive. Here at omega t equals to 0, it is minus Vmax sin phi, because sin minus phi is minus sin phi, so it becomes minus Vmax sin phi, it is negative. So this is the concept of the initial phase angle. So when there is no initial phase angle, the 0 point starts at the origin. Okay, the 0 point of the signal, this 0 point, 0 magnitude, 0 point means 0 magnitude point, where magnitude is 0. Vt is equal to 0 or It is equal to 0. It starts at the origin. Okay, here the phase angle is 0 degree or radian. So it is simply Vt is equal to Vmax sin omega t, or It is equal to Imax sin omega t, with no initial phase angle. No initial phase angle. But here there is some initial phase angle. It is leading type, which is omega t plus phi, which is slightly to the left of the origin the 0 point occurs. Okay, and it has some initial value plus Vmax sin phi at omega t equals to 0. Here the 0 point of the signal occurs to the right of the origin by phi, and it has some initial value which is negative at omega t equals to 0, which is minus Vmax sin phi. Okay, and here it is omega t minus phi, here it is omega t plus phi. Omega t plus phi leading, omega t minus phi lagging. Okay, then let us say we have two waveforms which have the same angular frequency or same frequency, because omega is equal to 2 pi f. Omega is equal means f is also equal. Let's say we have two signals. Let's say Vt is equal to Vmax sin omega t, It is equal to Imax sin omega t minus phi. They have the same frequency, but they have different phase angles. Here it is omega t, here it is omega t minus phi. It means omega t minus phi will be lagging. Okay, its 0 point will be slightly to the right of the origin by amount phi. Okay, this is lagging, by V is leading. Okay, so in other words, you can also express this as Vt is equal to Vmax sin omega t plus phi, and in that case you will write It as Imax sin omega t. So you have two choices, whether you can write Vt is equal to Vmax sin omega t and It as Imax sin omega t minus phi, or you can write Vt as Vmax sin omega t plus phi, It as Imax sin omega t. In either of the cases, It should be lagging, Vt should be leading. Same way, if we have to compare this two, okay, here Vt is equal to Vmax sin omega t, It is equal to Imax sin omega t plus phi. Both have the same angular frequency or the same frequency, omega is equal to 2 pi f. Here Vt is equal to Vmax sin omega t, it is starting from 0, its 0 point occurs at omega t equals to 0 or t equals to 0. It has no initial phase angle, but It has some initial phase angle. Okay, It has some initial phase angle. Its 0 point occurs to the right, to the left of the origin by phi radian or phi degree, this much. Okay, this much initial phase angle. So it has, at t equals to 0, it has some initial positive value. In this case, at t equals to 0, this I, it has some negative value here. okay, some negative value. Here I has some positive value, all the characteristics of initial phase angle. So here this plus sign indicates that IT is leading, the current signal is leading and the voltage signal is lagging. So here you can alternatively express it as Vt as Vmax sine omega t minus phi, It as Imax sine omega t. You can write it in this way or this way, but I think this choice, this representation is appropriate. This is appropriate. You stick with this. Vt is Vmax sine omega t, it is the reference, and from this current is leading by phi radian or degree. It is slightly to the left. Here Vt is the reference, Vmax sine omega t, and It is lagging because the 0 point is slightly to the right by phi. Okay, so this is the concept of phase difference between two AC signals, and two alternating quantities can only be compared for phase difference when they have the same frequency, same angular frequency or same frequency. So the 0 points, the difference between the 0 points. So here the 0 point is here, the 0 point for the voltage signal is here at origin, here the 0 point of the current signal is here. The difference between the 0 points is phi radian or degree on the omega t axis. This is the difference of the 0 points. Similarly here the 0 point of the voltage signal occurs here, the 0 point of the current signal occurs here. The difference between these two 0 points is the phase angle phi. Okay, so this is the concept of phase and phase difference. Okay, so this is the thing.